Hi, my name is Garth Gilmour and I'm the head of learning at Instill. I've been in the industry since the 90s. As regards Kotlin, I'm a certified Kotlin trainer, a Google developer expert in Kotlin and co-organizer of the Belfast Kotlin Users Group. The story behind this video is that we did a Belfast KEOGH event in October, which was very successful, and we wanted to keep the momentum going. But come November, there seemed to be a certain sense of fatigue and ennui in the community for entirely understandable reasons. And we eventually reached the conclusion that an event in December would be a bridge too far. But we still wanted to give something back to the community before the end of the year. So we came up with the idea of a Kotlin Christmas Stocking, where we would invite well-respected contributors, both local and international, to give one or more recommendations for developers. And these would be resources for coders either starting into Kotlin or trying to improve their existing skill set. And this is the result. So I hope you find these worthwhile, and on behalf of everyone involved, have a very safe and enjoyable Christmas.
Hi, my name is Kate and I'm a developer advocate for Kotlin. I love Christmas for all the magic atmosphere that you can feel almost everywhere, even if you are surrounded by palms and sea. And of course, I love Christmas because of gifts. Books are great as a gift. Maybe it's a little bit ordinary, but it always works. So the first thing I would put in Kotlin developers' Christmas stocking is the book Code, the hidden language of computer hardware and software. It gives you the slow unfolding of how computers actually work. It leads you from very basics like Morse and Braille codes, like simple light bulb circuits, to logic gates, to RAM, to keyboards and monitors, to how low-level programming languages work. It won't actually help you to learn Kotlin, but it will help you to understand what magic going on around when you write your code. At least it's curious, and as far as I know, engineers are really curious kind of people. And after reading it, you will become an expert at explaining how computers work, and you will be able to explain it even to your grandma. The next thing is something more practical and closer to what I'm thrilled with: Kotlin multi-platform mobile. I believe that each developer who would find Camp Kit in their Christmas stocking would be able to create their first cross-platform mobile application with KMM in a short time and without a headache. Camp Kit is a collection of source code and tools designed to get your mobile team started quickly with Kotlin multi-platform. The thing I love most about it is that besides source code of sample KMM application with basics feature set, it also contains educational resources, which would become great addition to the official documentation because they are written by KMM adopters with a first-hand experience. So if you ever want to try KMM, that's a great place to start. Merry Christmas and take care!
Hi, my name is Josh Long. I'm Josh at joshlong.com or at Starbucksman, STARBUXMAN on Twitter. I've been working on the Spring team as the first Spring Developer Advocate since 2010, and in my capacity as a Spring Developer Advocate, I've naturally sort of explored a lot of interesting, albeit adjacent communities, and so as a consequence of that, I'm also a Java champion, and more recently a Kotlin Google developer expert. I love technologies because they make it easier for me to build software that's destined for production. So, as for the things I'd recommend, well, of course, I might recommend my recent book, Reactive Spring, or Dr. Subramaniam's epic recent book on Kotlin, for which, by the way, I was a reviewer and a contributor. But these are a bit low level. They'll open up some interesting technical avenues, but generally, I'd advise you to stick to the higher order paradigm changing kind of stuff, especially if you have some downtime this holiday season and want to change your frame of mind. So, 3 books spring to mind, pardon the pun. First of all, Continuous Delivery by Jez Humboldt and Dave Farley. Kind of a classic now at this point. It's been around, it was 2009, something like that. The book talks about the patterns that organizations embrace to create feedback loops, right, in their software. So very, very interesting book, right? You're gonna find very little discussion of Java or Kotlin or anything in there, but very, very interesting book. The Phoenix Project is, I think, the lowest friction sort of books to read, and it might have the biggest impact. The book is, well, first of all, it's a book, but it's also an audible book. You can actually listen to it if you want, because there's no code per se in the book. It's a discussion about a hypothetical organization that is struggling with some existential political and technological problems. And the book sees the protagonists embrace different methodologies, different practices that modernize the organization and help them as a microservices creating, cloud computing aware, lean manufacturing aware, test-driven development aware, continuous delivering organization. It helps them go faster and do so in a more safe, more robust, more satisfying way, so that the organization gets what it needs when it needs it. And finally, if you'll permit me a third recommendation here, Michael Nygaard's seminal tome, Release It, is an amazing book. It's all about everything that's after you've written the last line of business differentiating functionality, what you have to do to take an idea from concept all the way to the customer and production, right? There's a lot of stuff after you've written what you think is a working feature before that thing can go into production. And so getting that right, having a sense of what you don't know, game changing. This is also a very old book. It's probably, what is it, 2007, something like that, I think, 2008, before 2010. Okay, it's a great book, absolutely well worth read. And it holds up better today in the era of cloud computing and microservices than ever before. So with that, my friends, happy holidays. Thank you so much for listening, and stay safe out there, my friends.
Hey, this is Tom here from TomPryerDev.com. I've been doing quite a lot of coding in Kotlin over the last couple of years, and I really love the language because it's really a language just for getting things done. But not only for getting things done, it's a language for getting things done in a safe way. And one of my favourite features is Kotlin's support for null safety and really avoiding those dreaded null pointer exceptions. Another thing I really love to do is to try and use immutable data wherever I can. And sometimes there's a perception that if you use immutable data structures that you have to pay a performance penalty, but that's not necessarily the case. And one of the solutions for this is to use immutable persistent data structures. So there's a really great book to show this technique in Kotlin, and it's called The Joy of Kotlin. It's written by Pierre-Yves Samon. So this is my book recommendation, and I really recommend this for learning how to build immutable data structures from the ground up that are also efficient.
Hey, I'm Ellen Shapiro. I do mobile for Apollo GraphQL. And I wanted to give my stocking stuffer for Kotlin Christmas as Ahmed Al-Hou's talk from Kotlin Conf 2019. It was really, really good. I remember watching that talk in person and just being absolutely blown away at both the quality of the talk and the quality of the work that they'd done, integrating Kotlin multi-platform into a fairly large application, and really getting buy-in from their iOS team to be able to work with it. I think it's a great talk, and I think it would be a great way to celebrate Kotlin multi-platform.
Hi, my name's KEVLIN. I'm an independent consultant, trainer and writer. I'm based in sunny Bristol, which is where I'm going to deliver you your Christmas gifts. Okay, so you're a Kotlin programmer. What's your programming paradigm? And you talk to different Kotlin programmers and they'll tell you different things. It's running on the JVM, it's statically typed, so I guess it must be object-oriented because that's kind of where Java comes in. I hear some people claim that Kotlin is functional. It definitely isn't. It's a very procedural language, but it offers you some support for functional programming or makes certain aspects of its style easier. But it has a lot in it that kind of dates back to the 1960s, 70s, and 80s when it comes to concepts of control flow. But of course, there are those elements that a number of languages have adopted more recently and they claim are functional. Things like lambdas, which are not intrinsically functional, but we find the idea of blocks and closures all across the programming language space. Object-oriented languages have it as a fundamental part. Similarly, procedural languages, that was one of the classic features that they had, was anonymous procedures in the old days, something that kind of got lost in translation as time progressed. But perhaps it's a modular language as well. It has good support for component-based development. These are all these different paradigms. In fact, the problem is trying to nail it down to one paradigm. So the first thing I'm going to offer you is a paper. You can Google it. It's by Robert Floyd, The Paradigms of Programming. It was published in 1979. You can find PDFs online. And it was, Robert Floyd was awarded the Turing Award in 1978. You may not have come across his name before, but he basically came up with the basic formalism that led Tony Hoare later in 1969 to come up with this idea of formal reasoning for code based on a precondition, an operation and a postcondition. And this was kind of Robert Floyd's idea. These days we tend to refer to this as given, when, then. Precondition, operation and postcondition. So Robert Floyd has been very influential in a number of aspects. Language work, programming work, and so on. He's also the guy who introduced us to the word paradigm. It was not a new word, but he introduced it in the context of software development. Historically, paradigm had meant a pattern or an exemplar or an archetype. And then Thomas Kuhn's work on the structure of scientific revolutions kind of propelled us into the idea of it's a kind of mode of thinking that dominates a field. And he gave us the idea of paradigm shift. And Robert Floyd applied this in the late 70s, and it's from him that we start using the word paradigms in programming. So I always recommend that people are aware of this paper if they're going to use the P word, the paradigm word. Because one of the most important things that he says is he looks at the paradigm space much more richly than we often do. And some people think that there's only functional and procedural and objects, and no, there's a lot of paradigms. And many things that we attribute to just functional are actually, some of them are actually quite different sub-paradigms. We haven't even talked about things like concurrency. These are all questions of how do we structure flow, how do we structure data, how do we organize structure, how do we organize time. These are all the aspects that matter. But what he's calling for is not that we should find the one true paradigm. He actually makes a point that he complains that we're not very good at understanding or supporting the paradigms, plural, of our users, when our users are programming language users in that sense. He looks at a paradigm as a way of solving a problem. These days we might refer to this more as an architectural style or a pattern. But his goal is to talk about the plurality of this, that we want multiple paradigms and better support for them. Kind of remaining in the 1970s, I'll give you something to watch as well. Brett Victor's talk in 2013, The Future of Programming. Although it was delivered in 2013 at the Dropbox conference, DBX, what he's actually talking about is he goes back to 1973 and he talks about imagining what the future of programming will be like in 1973. And he does this very authentically. He says, well, what are we going to be doing in 40 years' time? It's 2013. It's a half-hour talk, but he does this so authentically, he's actually even using an overhead projector. And he's only talking about research and work that's been done in the 60s and 70s. And he talks about interactive programming. He shows you the possibilities of what computers could become based on what we knew then. It's almost a little bit disappointing in that sense. It's also very entertaining and very informative. He talks about programming and what should be a more interactive approach, but he also talks about how we should be thinking about it. We should be moving away from instructing the computer, the imperative idea, the procedural idea, to a more declarative idea based on goals and constraints, logic programming and things like that. And also decentralization, getting rid of the idea of a control flow centered based approach. And that is quite important. Control flow is the obsession, as it were, of procedural programming. We see a lot of that, say, in Kotlin, which is obsessed with all kinds of ideas that went out of fashion in the 1970s and 1980s, such as labeling things and having jumps to labels and all this kind of stuff. That was a fashion that died out by the 1990s. Likewise, coroutines, it's nice they're making a comeback, 1950s idea. but they're still a control flow approach. He's looking at something much richer, and he emphasizes things like Carl Hewitt's actor model, which was 1973, and the richness of that. So I would offer you both this talk and this paper as a way of kind of opening up the possibilities of your programming rather than trying to, as it were, narrow it down to something small. Make it bigger. Merry Christmas.
Hello, I'm Nat Price, and my contribution to the Kotlin Christmas Stocking are these books. The Architecture of Open Source Applications, Volumes 1 and 2, edited by Amy Brown and Greg Wilson. Each book is an anthology. Every chapter describes the architecture of a well-known piece of open source software, and most chapters are written by the authors of that software. So you get expert explanation of how the software works, but what I found more interesting is also the authors explain why it works that way, how it got that way. So they'll start off about talking about why did they write the software in the first place, and then how did it evolve as other people used it and wanted it to do slightly different things. How did they adjust the design to handle the variation that people wanted or new situations that the software was used in. And also, what mistakes did they make along the way, and what lessons did they learn from those mistakes, and how are those mistakes still existing in the software, or how did they work around them or get rid of them by improving the design. So the book cover all sorts of applications, from Git and Bash, Hadoop file system, SendMail, all the way up to user-facing applications on the desktop like Audacity and Telepathy, which are an audio editing application and a messaging application. So lots of in-depth knowledge, warts and all description of how software is actually written, from people who are doing it day by day and have tended these applications for years. And so really useful way of real useful source of understanding how software is developed. I love seeing these warts and all histories to learn from other people's mistakes so that I don't have to make quite as many. And the other good thing is that proceeds from the sales of these books goes to Amnesty International. So not only can you learn lots about software development, you can also help make the world a better place as well. So win-win. And happy Christmas.
Hello, I'm Maurice NAFTALIN. I'm a Java champion. I've been working in Java since there was a Java. And I've written a couple of books on Java 5 and on Java 8, and I do conference talks. So recently I've been giving a talk with Dmitry Vyazelenko called What Lies Beneath, and this is about what happens when your Java program really executes. And we took it from source code down to bytecode all the way to the hardware. What lies beneath is relevant to what I want to talk about today, which is what I would give a Kotlin somebody learning to program in Kotlin for their Christmas stocking. And my chosen present is, for an admittedly pretty strong Christmas stocking, is this book. This is Computer Architecture: A Quantitative Approach. It's the 5th edition. There's now a 6th edition, which came out in 2017. This edition is from 2012. And that tells you quite a lot in itself, because the Hennessy and Patterson, besides their day jobs, which include being things like the president of Stanford University, have been revising this constantly since 1990. So for nearly 30 years, they've kept it up to date with the development of computer hardware and modern ideas of computer architecture. So it's an encyclopedia of hardware knowledge. So if you want to learn about the price performance power ratio, trade-offs for in chip design, if you want to learn about instruction level processing and about the memory hierarchy and speculative execution and branch prediction, or about data level parallelism and SIMD architectures, or about thread level parallelism, shared memory, cache coherence, so on. Or if you want to know about how these architectures can be scaled up to warehouse level computing, this book will tell you all about those things, and it will tell you about them with hard numbers. So it's not arm waving. Here you'll get the word calculations. So I can't say that I've read it in detail and worked through every example. And a little anecdote is that Heinz Karbutz, who's quite a well-known Java programmer and author, challenged me to a competition to see who could finish it first. And I'm afraid that competition remains unwon by either of us. So a serious question is, why should a high level somebody programming in Kotlin want to learn about this stuff? And I've got two answers to this, and one of them is that what they write in the preface. They said even in the first edition they wanted to tell you about computer architecture, Hennessy and Patterson, and they said in the first edition, it is not a dreary science of paper machines that will never work. No, it's a discipline of keen intellectual interest requiring the balance of marketplace forces to cost performance power, leading to glorious failures and some notable successes. And I think a keen discipline of keen intellectual interest is something we should want to know about. So that's one reason why I recommend reading this book. And the second reason is that I think if you want to be a better programmer in Kotlin or any other language, including any other high level or even lower level language, you should want to journey below the nice abstractions that those languages give you, and understand, at least in broad outline, what lies beneath. Even if mere mortal developers like Heinz and me and you never actually complete that journey, to have made even part of it in the company of Hennessy and Patterson is reward enough in itself.
Hi, my name is Adele, carpenter, software engineer, and ugly Christmas sweater enthusiast. Now, like a lot of events that were scheduled for 2020 in person, Kotlin Conf has needed to be postponed until 2021. So that has left a little bit of a hole in people's calendars, including myself. But I thought, what better way than to fill this hole and our Christmas stockings than with some highlights from the Kotlin Conf back catalogue. So the first talk for me that comes to mind is called Dissecting the Standard Library by Huyen Tui Dao. This gives a strong overview of the idiomatic features of the Kotlin language. It can go quite deep at times for an overview, but it doesn't matter if you don't absorb everything right away. It's still a really good talk to see, so you know what's coming up for you as you get deeper into the language. Following up from that, in 2019, I did see this talk live from Huyen again, is called Putting Down the Golden Hammer, which is actually a little bit of a flip side to the first talk where she really promotes all of the features. This second talk is more of being a bit more measured in when to apply these excellent features and when to maybe be a little bit more explicit. I really recommend both talks. The excellent thing also with these talks is that they recommend other talks in the talks. So it basically is the gift that keeps on giving, and that's what makes them an excellent stocking stuffer. Now, of course, it would not be a Kotlin Conf without the Kotlin Puzzlers by Anton Kex. This is also a bit of an internet phenomenon as well, where people are encouraged to submit proposals that highlight the peculiarities of the Kotlin language. I managed to see the third version in 2019 in Copenhagen live. It was a lot of fun, and I do recommend watching these online. What I would say is to maybe make use of the pause button and to challenge yourself as he goes through the puzzlers to see if you can work them out yourself. Now, of course, you can also jump down the YouTube rabbit hole yourself. You don't necessarily need me to give you an outline of every single talk to see, but those two people I would definitely start with. Now, outside of the Kotlin Conf landscape, I have one final talk that I do recommend for you. This is called The Art of Code by Dylan Beattie. This was actually the last talk that I saw live in 2020, which feels like a very, very long time ago now, and it is on the YouTube channel for NDC London. So I definitely recommend that talk, The Art of Code. It's very lighthearted, and if you're a bit of a programming nerd like me, it's the perfect stocking stuffer. So those are my recommendations for you today, and that's it from me, and I do wish you all the best for what is sure to be a unique festive season.
Hi everyone, my name is HARIRI, and amongst other things I run the developer advocacy teams at JetBrains. Here are my recommendations for the Christmas stocking. Now you might be thinking, what's wrong with HADI? He's recommending a Haskell book on a recommendation for something related to Kotlin for a stocking. Yes, that is absolutely correct. I think that it's very important for us to learn multiple languages, even though we may love one more than another. And what's even more important or interesting, I would say, is to learn about different paradigms. Now, if you're familiar with Kotlin, you know that Kotlin is an object-oriented programming language and also a functional programming language. You can kind of mix and match both. You can use one or use the other. But I think that when you come to Kotlin from other object-oriented programming languages, you kind of fall into that trap of doing things the way that you have always done and not really leverage or try and find different ways to do things, such as maybe taking a functional approach. Haskell is a language that is purely functional, and it's not only a great language to learn, but it is also a way for you to understand how to do things differently that don't put you into the same trap of doing it as you have done before, because it severely restricts what you can do in terms of object orientation, which is basically nothing. So it forces you to think always in terms of functions. And there's many books and resources on Haskell, but I found that Learn Your Haskell for Great Good is a really nice getting started one. And of course you can read it either for free, or if you have the means, buy it and help support the author, which you can get either in PDF format or as a print book. By no means am I suggesting that you drop Kotlin and move to Haskell, but my point here is to open up your mind a little bit around how things are done differently in different languages. And if you're going to be learning about functional approaches, what better than to learn? And then of course you can take these same concepts and apply them to Kotlin. My second recommendation, of course, what's it going to be? My own podcast, Talking Kotlin, which to date, even though it's been running for nearly 3 years now, there are folks that haven't heard about it. And so I interview folks and I cover multiple topics, and you can go and look at all of the different things that we've been discussing. So make sure you listen to that. It's on your favorite system that you use to listen to podcasts. And last but not least, over the holiday season, if you have time, why not pick up and play a little bit with Desktop Compose, which is essentially a new project that we have been working on at JetBrains with the idea of bringing Compose to desktops. So if you're familiar with Android, you may have heard of Jetpack Compose by Google. We're using the same technology to develop desktop applications. So take some time and play around with that. It's very early days, but maybe you have some nice feedback that you can share. With that, have a happy festive season and for a great new 2021.
Hi, my name's Richard Gibson and I work at Hex Labs in Belfast, mainly on tools for AWS. So my first recommendation for the Kotlin stocking filler, if you're new to Kotlin, is a resource created by JetBrains called Kotlin Cones. It's a set of over 40 tasks that are made to help familiarize you with Kotlin's features and syntax. It's easy to use. If you've got IntelliJ installed, you can install them via a plugin called the EDU Tools plugin, or just run each exercise in the browser on the Kotlin Cones website. Each task takes a few minutes to complete and is designed to introduce you to a specific Kotlin feature. It also comes with links to further reading, and answers are supplied if you get stuck at any point. So it means that within a few hours, you can really get a good flavour of what Kotlin's about. And it covers a large number of core features like data classes, nullable types, lambdas, generics, the collections API, builders, and much more. My second recommendation is a project that's been going for over 20 years. It's a set of challenges that are maths-based called Project Euler. It has over 700 different challenges, and each vary in difficulty. So some may take longer to complete than others, but most are solvable within a few lines. And my favourite part about these is once I have completed a challenge, being able to compare what I've done with others, just to see how they thought about it, how they tried to tackle these things. So it means that you can compare your Kotlin solution with others, but then also being able to compare yours with your solution with another language is also great. So because you understand the problem already, you can quickly see what that language is trying to accomplish and compare styles and paradigms. My final recommendation, if you feel you're up to speed with Kotlin, wouldn't really fit in any sort of stocking, but it's just to consider contributing to a Kotlin open source project. As the Kotlin ecosystem is growing, there are many open source projects about, and although if you haven't done so before, it might seem a bit daunting to make a first contribution, most maintainers would love extra support and are very happy to have newcomers come on board. They also like to pass on knowledge that's been picked up while building the library, so it's something where you would gain great experience. So if you're thinking about this, try starting with an open source project that you're already using. You can look in the Kotlin Line workspace on Slack. Most open source projects have got a channel in there, and you could ask if there's any issues for newcomers. And other projects will actually put labels on their issues, on their Git web pages, on their Git repositories. So yeah, give it a go. It's a great experience to try.
Hi, I'm Liz. I'm an agile coach and consultant, but I used to be a developer and I still code for fun. So the thing I would like to give you for Christmas is the KEVLIN framework. It's a framework for making sense of different situations and how to approach them, depending on how predictable or unpredictable things are. And the hardest thing about it is how to spell it. You spell it CYNEFIN. So now you know how to look it up. The reason I want to give it to you is because the thing it taught me is that when you do something new, it's going to be high discovery. It's full of unknown unknowns. And when we're doing software, we're always trying to do something new. We're always trying to provide a new capability to the business or to staff, or we're trying to get the capability with a new quality, some new context that it didn't have before. So our software developments, they're always driven by something new. When we're doing something new, because it's high discovery, we don't want to do too much investment in it until we can work out whether it's going to work, how it's going to work. So the way we do this is we spike, we prototype, we try and get something working, and that working software is at the heart of everything we do. Of course, when we're spiking or prototyping, it's not necessarily as tidy as it could be. So we're trying to get something working quickly. That means it needs to be a very expressive language that we're using. But then after we've got it working, we need to tidy it up. We need to stabilize it. Unless we're going to rewrite it, in which case it needs to be very good language. We need to have something that we're going to be able to refactor, to get under test, to make good. And that means it usually has to be statically typed. Kotlin's perfect for that. It's a highly expressive language, very statically typed, and I realise how good it is because I know the KEVLIN framework. I think that if you were to go and look up the KEVLIN framework, you would have a really great Christmas too. So, Merry Christmas.
Hi everyone, I'm Katie from New York City.
And I'm Shelby from Boston.
Happy holidays. We wanted to give you our favorite recommendations for your stocking stuffers. A few Kotlin Conf talks from 2019. The first one being The Power of Types.
The second one, Asynchronous Data Streams with Kotlin Flow.
And Testing by Christina Lee.
So we wanted to wish you all a happy holidays and tell you that next we'll be speaking at the Kotlin user group in Belfast, and we hope to see you there.
See you soon.
Hi, I'm Chris from Instill, from talking from my home office. My choice for the Christmas stocking is a talk by Roman from the Kotlin team on the topic of coroutines. What I particularly like about this talk is how Roman discusses the traditional approaches to server-side architecture, where long-running operations or calls to external systems are typically executed by a thread and will block those threads until completed. He then goes on to discuss approaches to asynchronous programming using callbacks and futures and RX before getting into details of how coroutines work and how developers can make use of coroutines to write code that not only scales well but is really easy to reason about. On the whole, I think it's just a really good intro to how coroutines work, and it's really, particularly for anyone coming from other JVM languages or languages such as C# or JavaScript, there's other approaches to asynchronous programming. Thank you.
Hello, my name is Matthew SNODDY. I'm a technical architect for KEOGH software here in Belfast. Today I'm going to talk to you about a few things that I think Kotlin engineers and engineers in general should have a look at over Christmas. So the first thing is the book I have on the screen here, The Pragmatic Programmer. So I own 2 copies of this book, both the original and the 20th anniversary edition. The reason I own 2 of these books is I think it's an invaluable resource, both for any engineer and for architects alike who want to understand better how we build solutions and software that is not only maintainable but actually uses patterns that will continue to evolve and work with the software over time. So this covers everything from how to manage your code, how to work with others, all the way up to how do I manage complex tasks like generating code and doing things that essentially might be opinionated in certain platforms and languages and may have their certain ways of doing things, but this book tries to approach it from a generic standpoint of how do I build solutions that essentially will be, in 5 years, will be as maintainable as they are today, whereas quite often what happens is a pattern or a technology is used to try and sort of be the whole stand-in for just using good patterns. And again, it's not opinionated. It doesn't focus on any particular language or platform. It just says, here's how you can put things together. And, you know, I personally would recommend this to any engineer or any architect who is in that space of trying to work better and ensure that we understand how to get requirements from users and how to actually put them into a design pragmatically and how to actually translate all that into something that we can maintain rather than just picking up and trying to code. The second thing that I would like to mention is Jack Cesari's talk on Java performance. So Jack does a very good overview here. Obviously has a vast amount of experience in tuning the JVM. So be that you're running on an Android device or you're running back-end code in a server or whatever it is, the JVM has its own quirks and things you need to understand about it. So some people may be working with a very recent JVM, be that 11, 12, 13, 14, or they may be working with a very old JVM, so be that 8 or earlier if you're unlucky. And essentially, he does a good job of covering sort of the topics that I've been close to over the past few years, which are things like memory management, garbage collection, multi-threading, things like understanding how the JVM interacts with the operating system and how to optimize that for your use case. So things like handling files and network sockets and stuff like this, and stuff that you typically don't think about for a very low level, one-shot application. But once you start getting into the tens or the hundreds of thousands of users spread across 10, 15, 20 servers, or spread across a cluster in Kubernetes, this sort of helps you understand what impact does the pattern that your code is using have on the JVM, and do you need to tweak that, or is it more just a matter of understanding how the JVM works and tuning it, which is something I think he gives a good overview of. Tuning the JVM is basically a subject within itself. I've spent many years on sort of production performance issues, dealing with issues ranging from the simple of making sure you're configuring your memory correctly, ranging up to the very complex, like things about how thread scheduling happens under the hood in the JVM, and how to make sure you don't get things like deadlocks and stuff like this. So I hope you find those useful. That was my 2 items, and have a good Christmas.
I am David McFarland, a principal engineer at RigUp and former instiller. My first recommendation is a video by Andrei Braslav at Google's 2018 I/O conference called How to Kotlin. If you listen carefully in the background, you can hear birds chirping. There's a wonderful accent, and he really knows how to work the podium. In all seriousness, it is a very concise comparison with Java on a number of the core language features, including type inference, data classes, functional programming, and coroutines. My second recommendation is the Kotlin Keep repository on GitHub. I know many of you enjoy a good lockdown cup of hot chocolate and a JSR. Kotlin's equivalent is Keeps and the Shepherd process. It's a great way to get insights into how features make their way into the language, the thought process, the limitations and the motivation for adding, and can give insights into where the language may go in the future.
My recommendations are 2 closely related books that cover similar ground but in different ways. The first is Professor Frisby's Mostly Adequate Guide to Functional Programming. So this isn't a Kotlin book. It uses modern JavaScript as a kind of lingua franca to introduce the core concepts of functional programming. It starts from scratch and incrementally builds up to advanced concepts like applicatives and traversable. I reread this book every 6 months or so, and each time I get a little bit more out of it. So for me, the valuable things about the book would be that number 1, it's accessible. The writing style is extremely clear and friendly. It's concise, no chapter is ever longer than it needs to be, and it's very matter of fact. So theoretical concepts like monads and category theory, they are introduced as you go, but never in a way that seems forced or overbearing or out of place. So it's a great resource, and you can start into it right now because it's available for free on GitBooks. My second recommendation would be Functional Programming in Kotlin, available from Manning. This hasn't been published yet. I've been reading it in MEEP, but it's the Kotlin version of a Scala book that has huge respect in that community. So it covers most of the same ground as the Frisby book, but it's organized into broader themes. It does a deep dive into the Kotlin syntax, and it's both more academic and more practical. More academic in that the theoretical concepts are explored in a lot more detail, more practical in that it covers applications such as property-based testing. When you compare the two, I would say that this one is more valuable to a Kotlin developer in the long run, but it's also very concentrated and dense. You know, it feels like an academic text that you need to work through 1 chapter per term. So what I would say is make a start with the Frisby book, and then when you have a good grounding and some confidence, start into this more Kotlin specific one. But as with most things in IT, remember it's a marathon and not a sprint. So you don't need to know everything right now, and incremental progress will build up over time into great results.